April 13th, 2015. Guys, you're looking at Earth-facing SDO images. We've been watching this top left quadrant for the last few days. Sunspots are growing. I said that more than likely they would go beta, gamma, delta in that lead group because of the different configurations, and they have. It is now beta, gamma, delta. But behind those, both at the top and the bottom where I have the red arrow, are two new emerging areas. It kind of makes an arrowhead there or a triangle. What's happening is, although we were supposed to be going into solar minimum for this type activity, it just has not occurred yet. These are strong and they're getting bigger. Again, the front lead object there, 2321 in this group, has gone beta, gamma, delta. That has increased the X flare chance to 20%, M flare to 55%. Now, we've seen this before, but not since Cern has been at this type of energy. And it's important, and I want to go into detail. But again, both of those sunspots that are bringing up the rear are larger than the ones we're dealing with now, so we're going to have to watch it. And also notice how active the magnetic lines of force are between this group of sunspots. That just adds to the energy. And you can see the one in the bottom emerging in that section also in this last few frames. All of that's a very active area. We're going to have to deal with it for the next 2 weeks. Now, this is where the whole video is leading to. In order to keep funding, Cern keeps saying they're looking for dark matter, but the University of Leicester has already proven that it exists, and that's what Cern is really trying to do, is absorb this energy. Coming from the center of the sun, they create these superparticles from that intense heat. They're called axions. Read the bottom of this. Pause it if you need to. It's called dark matter that's converted into photons, not protons, but photons, and they're entangled into the magnetic lines of force. And look at where they come, right into the Earth. Dark matter converted right into the Earth. Now, why is that important? Because of what's happening with our magnetopoles. We know that Cern is affecting that. Now, the Earth relies on this magnetic field more than you'll ever realize. Without it, it's a tiny ball in space. But the sun activates the entire rotation, the engine of the Earth that generates these magnetic lines of force, just like an electric motor does. Without it, we would not exist. Life would cease to exist. Also, even though we have the Van Allen radiation belt, guys, that you see as we're peeling back the layers of it here, those particles come through. And when you compress the magnetosphere, not only do those particles we're talking about, but extra UV radiation and other things. But notice the purple lines in the center. It's called induced ground current. Also notice on this diagram that the top of the Earth as well as the bottom is not particularly well shielded by either the Van Allen radiation belt or the plasmasphere. The yellow arrow is where Cern is, so that it's fully exposed. This is the key. This particular chart, and I want you to understand what's going on. The red arrows are what's called the field-aligned currents. Notice they come down into our planet. That's those giant lines that you see coming in and out of the planet when we show the images of the Earth's magnetic field. They come down, they hit the ground, they're induced into what's called Pedersen currents. Now you induce another coil into that called Hall currents. They're in the yellow. You see that? So when you get two coils close together, and I'll show you that in another diagram, you have coil induction, and you can increase, decrease the amount of current, amperage, the voltage, the entire thing that we're dealing with. But notice where the center of those yellow lines are. You see that particular line that goes right above 70 degrees? It cuts through the Great Lakes. That is exactly where they built Cern, in the center of these ground Pedersen currents that overlap with the Hall currents. Now we're going to add another coil to the entire scenario. Again, though, that's your Hall currents there. Now what if we put another coil? And guys, again, this is called induction. If you haven't studied electronics, you may not be following me, but we have now a 17-mile underground ring called Cern right in the center at 46.23 latitude. You see that? I'll get back to that. Remember that. But this is a coil. Now, For an example, I put Earth on the left as far as that coil, Cern on the right. Notice as that coil comes closer, the light bulb gets brighter. But what does it do at that time? I'll show you. But I'm going to flip it up to give you an idea of what we're dealing with. The image on the left, I've turned straight up instead of sideways. It matches the Earth's magnetic field, just to give you an idea of what we're dealing with. But as you pull these coils back and forth or turn Cern on and off the way that this light bulb image represents, it not only picks up that current, but it can distort the magnetic field. Do you see this? That's why you see that on our magnetopause. Now, they're saying there's no way because it's buried underground. It doesn't have to, it's not exposed to the currents in the atmosphere except through this ground current. It is a coil buried underground, the largest coil man has ever made, right on that point. You see that? So now as these ground currents come from space, flow through the Hall currents via the Pedersen currents, Cern is picking up that energy. Now, are they picking up the axions, that dark matter? But let's look at the locations on our planet. And this has to do with a lot of reports I've been getting about migraines, pressure, bad dreams, fatigue, sleeplessness, or extra sleep. But Cern is located here, right on the Franco-Swiss border, just south of Geneva. You notice the Geneva 15 airport to the right. Right there, we'll pull it up, you'll see what they call their dome of science, but it's actually another ripoff of one of Tesla's coils. They're his tower, if you remember. Notice the longitude and latitude, 46.23. Now, that's perfectly positioned to pick up that ground current that I'm talking about. That's how they're doing it. They have an above ground tower, several there, but it's the inducted ground current. That's why a lot of people are telling you guys that it can't be happening. But I want you guys to report, if you're in this area, are the headaches worse? Are the dreams worse? Is the fatigue, the sleeplessness, or the extra sleep, is it worse in that area? Remember, that's just the center line. It goes both north and south of that area, but pause that and take a look at it. Guys, they have Atlas back up and running. We were hoping it would stay down. But notice as they got beam 1 and beam 2 back lined up, the energy line started to rise. That's the black line. Now, this is what we were hoping Atlas Solenoid. Remember, they had to do the slow abort on it, and the energy in that second graph there had started to nosedive off. Well, it's back. Nothing we can do about it but observe it. But notice here, in this particular chart, the beam energy at 6.8 TeV, it was still rising, but in this chart, it's the green line on the left. Blue and red are your beam intensities. Now, this goes back from 0200 to 0200 today. That's, you're looking at a 12-hour period. Right there is when it started to peak this last time. You can see that both the blue and red beam had gotten very close together, both horizontally and vertically at that point. Again, it's new science. This is the first time, guys, you saw these blue lines peek their head up. That's Atlas. Look at the bottom left, bottom of the entire chart. Atlas is blue, Atlas is pink. First time, and it's after we saw that abort. Now, Atlas is the big machine, but now it's starting to kick. Are they getting closer to actually starting to get the magnets in shape for the collisions? And that's where it's really going to become dangerous if it gets to that point, because it already is vastly affecting the magnetopause. But again, guys, check out the longitude and latitude of where you're at on this planet, and pause this or go back and look at it again, because I know I threw a lot of information in there in a short period of time. But that's what's going on. It's a heads up. Be safe.